Assalamu alaikum. Today we're going to learn integration by substitution. Now, in questions of substitution, they have given you substitution. Like in this question, they've given u equals to 2x plus 1. You have to use this to integrate the function. As a first step, what you have to do is whatever is given to you as a substitution, you differentiate that. U equals to 2x plus 1. So du by dx is going to be 2. After this, you make dx the subject because you have to substitute dx here. Okay, whatever dx you will make the subject here, that will be substituted here. So you have to make dx the subject. If I make dx the subject, dx is going to be du upon 2. Okay, starting with the function here, 4x root 2x plus 1 dot dx. Now, in place of dx, I can write du upon 2. Okay, and in place of 2x plus 1, I can write u. 4x root u and dx upon du. Dx is actually du upon d2. Du upon 2. Okay, if I simplify, I'll be left with 2x root u dot du. Now, x can be substituted by, if you make x the subject from here, 2x plus 1. So 2x is going to be u minus 1 and x equals to u minus 1 upon 2. So in place of x, I can write 2 into u minus 1 upon 2 root u dot du. Okay, 2 and 2 will cancel out. That means you're supposed to integrate now u to the power half into u minus 1 dot du. If I multiply, I'll get u to the power half into 1, like u half into u1. Powers are added because the bases are the same, so it will be 3 upon 2 minus u to the power half. I'm supposed to integrate this now. Okay, when I'm going to integrate this, it will become u to the power 3 upon 2 divided by 3 upon 2. That means, first you add the power. 3 upon 2 plus 1 is 5 upon 2 divided by 5 upon 2, meaning multiplied by 2 upon 5, minus u to the power half. Half plus 1 is 3 upon 2. So I'm directly writing 3 upon 2 here. Divided by 3 upon 2, meaning multiplied by 2 upon 3 plus c. Okay, the integration is complete, but it is in terms of u right now. You have to revert back to the substitution. U is 2x plus 1. So in place of every u, you're going to plug in 2x plus 1 here. This is the answer. Starting with the next one. Okay, x equals to 2 tan of u. Okay, x equals to 2 tan of u. If I differentiate this, I'll get dx upon du is equals to 2 sec square u, because we know that the differential of tan is sec square. So 2 tan u will be differentiated and the result will be 2 sec square u. Now I have to make dx the subject. Dx is going to be 2 sec square u dot du. Okay, we keep it aside because we have to substitute dx by this whole thing. Okay, let's write it here. 8 upon x square plus 4 into dx. Dx is 2 sec square u. Now, in place of x, if I substitute 2 tan of u, okay, 2 tan of u the whole square plus 4. Okay. Now, if I simplify this, it will become 4 tan square u plus 4. 2 times x square u dot du. Okay. Now, we know sec square u is tan square u minus 1. Okay. And this can also be changed into sec square u. Okay, let's try this first. If I write 8, 4, we know that 1 plus tan square u is going to be sec square u. In place of tan square u, I can write sec square u minus 1. Okay, it's 4 sec square u minus 4 plus 4. Okay, minus 4 plus 4 will cancel out. 4 1 times, 4 2 times. So you're left with 4 sec square u upon sec square u dot du. This will cancel out. You're just left with 4 dot du. You have to integrate 4, and the integration of 4 is 4u plus c. Okay, so this is the result, but you have to revert back to the substitution. We have taken u as, what was u? Okay, if I just write it here, x equals to 2 tan of u. Okay, so tan of u equals to x upon 2, and u equals to tan inverse of x upon 2. So I can write 4 into tan inverse of x upon 2 plus c. This is the final answer. Okay. Use the substitution u equals to sin x to find sin square 2x and cos of x dot dx. Okay, so I'm writing u equals to sin of x, u dash equals to cos of x. Okay, now sine of 2x I know is 2 sin x cos x. So sine square 2x is going to be squaring both sides. It'll be 4 sine square x cos square x. Okay. Okay, so in place of sine square 2x, I'm writing 4 sine square cos square. 4 sine square x cos square x. Okay, and in place of cos x, I'm going to write cos x only. Dot dx. In place of dx, I know that du by dx is cos x. So if I make dx the subject from here, dx is going to be du upon cos x. Now this cos x and this cos x will cancel out, leaving 4 sine square x cos square x dot du. Okay, I know that u is equal to sine x, so I can write 4u square. And the first identity gives me sine square x plus cos square x equals to 1. So cos square x in terms of sine square x is 1 minus sine square x. Okay, so if I start substituting and using u equals to sine x, I can write this as 4u square into cos square x is 1 minus u square. Okay, if I multiply, I get 4u square minus 4u4 dot du. Okay, now I'm going to start with the integration process. If for integration we add the power, so 4u3 upon 3 minus 4u5 upon 5 plus c. Okay, what was u? It was sine x, so I can revert back to the substitution now. 4 upon 3 sine of x, sine cube x minus 4 upon 5 sine 5 x plus c. This is the final answer. Okay, use the substitution u equals to x plus 1 to find the integral of this. Okay, so u equals to x plus 1, du upon dx is going to be 1 only. Okay, so if I make dx the subject, dx equals to du. Okay, writing down 3 and 0. In place of x, I can write u minus 1. Okay, because u equals to x plus 1, so x equals to u minus 1 upon u minus 1 plus 1. In place of x in the denominator also, I'm writing u minus 1 plus 1 then. So you left with, in place of dx, I'm going to write du. So I am supposed to integrate this. Okay, so how will I integrate u minus 1 upon root u dot du? Okay, I'm going to divide both terms in the numerator by root u. So u upon root u minus 1 upon root u dot du, and the boundaries are 3 and 0. Okay, u upon root u is going to give you root u, and root u is u to the power half minus u to the power minus half dot du. Now I'm going to start with the integration process, so I'll get rid of the integration sign. Half plus 1 is 3 upon 2 divided by 3 upon 2, meaning multiplied by 2 upon 3, minus minus half plus 1 is half divided by half, meaning multiplied by 2 upon 1. Okay, so I have to put the boundaries now of 3 and 0. This will become 2 upon 3, 3 to the power 3 upon 2 minus 2, 3 to the power half. Okay, minus, obviously this is going to be a 0 and a 0 here. No, there's a minor mistake which I have made here. Okay, now see, if you either you substitute and revert back to the substitution, and in place of u write down sine of x plus 1. In place of you write x plus 1 and put the boundaries of 3 and 0. Okay, but since we are not reverting back to the substitution right now, what you can actually do is, we know that u equals to x plus 1, and x is, this is x, the boundaries of x, so x is 3, so it's going to be 4 here. And if I take the other one, which is 0, 0 plus 1, so u is 1 in that case. So since I'm writing this whole thing in terms of u, I have to put the boundaries of u, which is 4 and 1 in place of 3 and 0. Okay, so I have to put the boundaries of 4 and 1 here. Okay, this is going to be 4 here, this is going to be 4 here, and if I put the boundaries of 1, it will be 2 upon 3 minus 2. Okay, 4 is actually 2 to the power 2, so 2 to the power 2 to the power of 3 upon 2 minus 2 to the power 2 square to the power half minus, okay, 2 minus 2 upon 3 is 1 whole 1 upon 3, but with a negative sign. This will become 8 into 2 is 16 upon 3 minus 2 into 2, which is a 4, plus 4 upon 3. Okay, so 20 upon 3 minus 4, which is actually 8 upon 3 is the final answer to this question. Okay, moving on to the next question right now, which is here. Okay, given that I equals to x upon x square minus 3 dx, use the substitution u equals to x square minus 3 and show that I is equals to this. Hence find I. Nothing difficult, it's exactly the same thing which we've done so far. So the substitution is given to you and you have to differentiate it. U is x square minus 3. So du upon dx is going to be 2x, and if you make dx a subject, dx is going to be du upon 2x. Now in order to make the subject, if I want to make the subject, that means I have to shift it here. So obviously this is going to come down. So this is what I've done. Now in place of every x, now u equals to x square minus 3. So if I make x a subject from here, u plus 3 equals to x square, so x equals to square root of u plus 3. Okay, in place of x, I'm going to write square root of u plus 3 now, divided by u plus 3 the square root. Okay, what I'm going to do here is square root of x square minus 3. Okay, x square is going to be u plus 3. So yeah, because x is root u plus 3, so x square is going to be u plus 3. So x square is u plus 3 minus 3, and there's a square over it. So it's a square root of u left here, into dx, and dx we know is du upon 2x. And we know x is equals to u plus root u plus 3. I'm taking it from here. x equals to root u plus 3. So du upon 2x, in place of x I have written u plus 3. This will cancel out with this. So this and this will cancel out. You're left with u to the power minus half, or you can just write it as this just to prove that first. 1 upon root u dot u. Okay. And there's this 2 here. So this 2 is a constant, so you can, it's 1 upon 2 actually, which is going to go out. Okay, so I is equals to this, proved. Now we're supposed to integrate it. Okay, if I'm supposed to integrate it, it's 1 upon 2 root 1 upon root 2, meaning u to the power negative half dot du. Okay, now I'm going to start with the integration process. Minus half plus 1 is half, upon half meaning multiplied by 2 upon 1, so it's going to be 2 upon 1. So the result of integration is u to the power half plus c. U was x square minus 3 to the power of half, so I can put it in the square root plus c is the final answer to this question. Okay, moving on to the next question here. Okay, now I have chosen, there's 6 questions. I have chosen 2 of these. Okay, so I'm doing this one, which is called the D part. Okay, so I'm doing the D part firstly. It's here. Okay, we know u equals to e to the power x plus 2, so du upon dx is going to be e to the power x only. Okay, so if I make dx the subject from here, dx is going to be du upon e to the power x. Okay. Okay, u equals to e to the power x plus 2, so e to the power x can be substituted by u minus 2. So I'm writing u minus 2 here. Okay, inside the bracket you have e to the power x plus 2, so e to the power x is u minus 2, so u minus 2 plus 2 dot dx. In place of dx I can write du upon e to the power x, and e to the power x is actually u minus 2, so here I can also write u minus 2. Okay, let's see, this whole thing will cancel out with this thing, and you're left with root integration of root u dot du, which is actually u to the power half. So integrating this, half plus 1 is 3 upon 2 divided by 3 upon 2, meaning multiplied by 2 upon 3. Okay, so this will become, the result is 2 upon 3 u to the power 3 upon 2 plus c, and we know u is actually e to the power x plus 1, so I'm going to write, in place of u I'm going to write e to the power x plus 2 to the power of 3 upon 2 plus c. This is the final answer to this question, which is actually the D part of question number 2. Okay. Moving on to this one. Okay, we know u equals to sine x. Du upon dx is going to be obviously cos x, and if I make dx a subject, it's going to be du upon cos x. That means this cos x can be cancelled out with this one when you substitute in place of dx, when you substitute du upon cos x, so no worries for this one. Okay, let's write it down. Cos of x, sine x is u, so sine to the power 5x is going to be u to the power 5. Dot, in place of dx I can write du upon cos x. This cos x and cos x will cancel out. You're supposed to integrate u to the power 5 dot du. Okay, 5 plus 1 is 6 upon 6 plus c. Okay, what was u? U was sine x. Sine 6x upon 6 plus c is the final answer to this question. Okay, moving on to this one now. Okay, let me do this as well. Okay, u equals to 5x plus 1. So u dash is going to be 5. Or you can write du upon dx here. That means dx is actually du upon 5. Okay, u equals to 5x plus 1. So 5x equals to u minus 1. So I can write u minus 1 upon u minus 1 plus 1 dot, in place of dx I can write du upon 5. Okay, I'm taking it from here. Okay, you are left with u minus 1 upon u and 1 upon 5 here. So 1 upon 5 is a constant, so I can put it outside. Okay, let's integrate this. 1 upon 5, u upon u is 1 minus 1 upon u is u to the power minus 1 dot du. Okay, now integration has become very easy. It will be u minus u to the power, it's 1 upon u, so I can write it as 1 upon u, which is actually ln u. Integration of 1 upon u is ln u. It will be u minus ln u. Okay, and obviously a plus c here, so the final answer will be 1 upon 5u minus 1 upon 5 ln u plus c. And what was ln actually? What was u actually? U was 5x plus 1. So now in the final step I can substitute u for 5x plus 1. This is the final answer to this part. If you want, you can multiply 1 upon 5 by this, so it will become x plus 1 upon 5, and then you can write down this whole thing as it is, or you can leave it like this also. There's no problem with that. Okay, doing this one. Given that I equals to x square upon 1 minus x square, use the substitution u equals to sine theta, x equals to sine theta, to show that. Okay, fine. Let's use the substitution. The substitution is x equals to sine theta. So dx upon d theta is going to be cos theta, and if you make d theta the dx the subject, dx is going to be cos theta d theta. Okay. Now in place of x, I'm going to write sine square theta. Sine square theta upon 1 minus sine square theta dot dx. In place of dx, I can write cos theta dot d theta. Okay, 1 and initially the boundaries are 1 and 0, but that is for x, not for theta, so I can change the boundaries. If I use this, x equals to sine theta, so x is 1 sine of theta. We know sine of theta is 1 at pi by 2, so theta is pi by 2, so I can write pi by 2 here, and once again it's 0 equals to sine of theta, and we know theta is going to be 0 at 0, so it will be pi by 2 and 0 are the boundaries now. Now we have the first identity, which is sine square theta plus cos square theta equals to 1. So cos square theta equals to 1 minus sine square theta. In place of this 1 minus sine square theta, I can write cos square theta. So this will become sine square theta upon square root of cos square theta into cos theta dot d theta, and the boundaries are pi by 2 and 0. That's what I'm writing. Square root of cos square theta is going to be cos of theta. So sine square theta upon cos of theta times cos of theta dot d theta. This will cancel out, and you're supposed to integrate sine square theta. Now we can use the trigonometric identity for cos of 2 theta is equals to 1 minus 2 sine square theta. So sine square theta is actually 1 minus cos of 2 theta divided by 2. So in place of sine square theta, I'm writing 1 minus cos 2 theta upon 2 dot d theta. The boundaries are pi by 2 and 0. Now I can integrate. Separate 1 upon 2, I can put it outside. Integration of 1 is theta minus integration of cos theta is sine 2 theta divided by 2. Okay, since I've done the integration, I will change this integration sign into the bracket, pi by 2 and a 0. Okay, so half outside, pi by 2 minus half sine 2 pi by 2. Okay, this is the first bracket, minus 0 minus half sine of 0. So this whole bracket is going to become 0 because sine of 0 is a 0. Let's simplify this. It's half pi by 2 minus half. Sine of pi is a 0, we know. Sine of pi is 0. So half into 0. Half into pi by 2. And the answer is pi by 4. Okay. In the first step, they had asked us to show that this is equals to sine square theta. So we had shown it here. So yeah, so this is the part where we had shown it. So you can write shown here or proved. Okay, and this is the answer to the second part, pi by 4. Okay, find the exact value of each of these integrals. So I'm doing a few from here as well. I'm doing 2 from here. And then I'll do one more question after that. Okay, find the exact value of each of these. So I'm doing this one right now. We know the substitution which we have to use is u equals to 3 minus root x. Okay, so if you differentiate this du by dx, differentiation of a constant is 0 minus the differentiation of root x is actually you write 2 outside, root x inside, and differentiation of anything which is in the root, like for instance 2x plus 3, is you write this whole thing down in the denominator, you write a 2 here, and then you differentiate it and write it up here. Differentiate what is inside this and write it up here, and then you can simplify. Okay, if for instance, just an example, if it is root 3x square plus 5x minus 6, how will you differentiate this? Dy by dx is going to be exactly the same thing down here, 3x square plus 5x minus 6. Differentiate this bracket and write it up. You have to write a 2 here, it's a part of the formula. Differentiate the whatever is in the square root, which is 3x square plus 5x minus 6, differentiate it and write it up in the numerator, 6x plus 5 here. Okay, so this is the answer. Now if I have to differentiate this thing, this whole thing will go down, 2 is a part of the formula, and then you differentiate x, you get 1. So this is the answer of the differentiation. So du upon dx is minus 1 upon 2 root x, and if I want to make dx a subject, dx is going to go on to that cross multiplying, du times 2 root x equals to minus dx, and dx is going to be minus 2 root x dot du. Okay, so in place of dx I can write this whole thing. Okay, so it's root x. Acha, also if I make root x the subject from here, it will be root x equals to 3 minus u. Okay, so that's why I'm going to substitute. In place of root x, I'm going to write 3 minus u upon 3 minus root x. So 3 minus u here. Dot dx. In place of dx, I can substitute the value of dx, which is minus 2 root x dot du. Okay, if I simplify this, okay, changing the boundaries in a while, but let's first simplify this. It's 3 minus u upon 3 minus 3 plus u minus 2 root x dot du. Okay, so I have in place of 2 root x also I can substitute, I can make a substitution. U equals to 3 minus root x, so root x is going to be 3 minus u, so 2 root x is going to be 6 minus 2u. Okay, so in place of this I'm writing 6 minus 2u. Okay, I've got 3 minus u and 6 minus 2u on in the numerator divided by u dot du, and I'm supposed to integrate all of this. This will become, if I multiply the two brackets, I will get 18 minus 6u minus 6u plus 2u square upon u. I first multiplied 3 by 6, I got 18. 3 by minus 2u minus 6u minus u by 6 minus 6u, and minus u by minus 2u is plus 2u square. Okay, so this is now 18 minus 12u plus 2u square upon u. If I divide all of it by 18 by u, I'll get 18 upon u. That means 18u to the power negative 1 minus 12 plus 2u square upon u is going to be 2u only. Okay, now I'm going to start with the integration process. This will become 18u to the power minus 18 upon u basically is actually 18 ln u. Okay, if you have to integrate it. Okay, because if you bring it up, so minus 1 plus 1 will become 0, so you have to do it with ln only. So this can be written as 18 ln u minus 12u plus 2u square upon 2. Okay, simplifying it further, 18 ln u minus 12u plus u square. And now look at the boundaries. First of all, the boundaries which were given were for x. Okay, now looking for the boundaries. Okay, u equals to 3 minus root x, and the boundaries for x, so x is 4. So if I write 3 minus root 4, it is actually u equals to 3 minus root 4 is 2, which is 1. Okay, so the upper boundary is 1. Now the lower boundary, u equals to 3 minus x is a 0. So 3 minus 0 is 3. So 1 and 3. Do not change this, swap them just because 3 is a bigger number, 1 is a smaller number. But no, let it be like this only. Okay, since we've already done the integration in this step, we will just write it like this: 1 and 3. Okay, let's put the boundaries of 1. It will be 18 ln 1 minus 12 plus 1. This is the first bracket. Minus 18 ln 3 minus 36 plus 9. Okay, we know ln 1 is a 0, so it's going to be 0 only. In this bracket you have minus 11 minus 18 ln 3 minus 27. Okay, minus 11 minus 18 ln 3 plus 27. 27 minus 11 is 16 minus 18 ln 3 is the final answer of this question. Okay, hold on for a while. Okay, moving on to the next question, which is this one. Okay, we know x equals to 2 tan theta. So dx upon d theta is going to be 2 integration differentiation of tan of sec square theta. Okay, so in place of dx I can write 2 sec square theta d theta. Okay. Okay, let's do it. 5 upon, in place of x I have to put 2 tan theta. 2 tan theta square plus 4 the whole square dot dx, which is 2 sec square theta dot d theta. Okay, also let's deal with the substitution right now only. If x is 2 tan of theta and we know x is 2, so x equals to, if x is a 2 equals to 2 tan theta, so tan theta is equals to 1 and theta equals to pi by 4 obviously. Okay, because tan of pi by 4 is 1, that's why. Okay, so in place of this I'll write pi by 4, and if it's a negative 2, this will be a negative 1, so theta is going to be negative, tan theta is equals to negative 1. That means it's going to be tan theta is negative 1, so just hold on. Negative pi by 4. Okay, so it's going to be negative pi by 4 here. Okay, let's just change this. It's going to be 4 tan square theta plus 4. Okay, 5 upon, if I take out 4 as common, I'll be left with tan square theta plus 1 times 2 sec square theta times d theta. Okay, we know 1 plus tan square theta is equals to sec square theta. So in place of 1 plus tan square theta, I can write sec square theta. You're left with 5 upon 2 only, and you have to apply the boundaries of pi by 4 and negative pi by 4. Okay, let's integrate 5. A constant is going to be 5 upon 2 theta. Okay, the boundaries are pi by 4 and minus pi by 4. The answer is 5 upon 2 into pi by 4 minus 5 upon 2 into negative pi by 4. Okay, it's 5 upon 8 pi. Okay. Plus 5 pi upon 8, which is actually, if you take out it's 10 upon 8 pi, which is 5 upon 4 pi. Okay, let me just quickly go through the question again. Okay, there's a minor mistake which I have made, which I have to correct now, and that is I had put a square here, but I forgot to put the square here. Okay, so let me just quickly correct it. Starting from this step. there's a square over it. Okay, so if I take out 4 as common, I'll be left with tan square theta plus 1, and there's a square here into 2 sec square theta. The boundaries will be pi by 4 and negative pi by 4 in every step. Okay, we know tan square theta plus 1 is sec square theta, so it will be 5.4 sec square theta square into 2 sec square theta. Okay, so it's 5 upon 16 sec 4 theta into 2 sec square theta. If I simplify it, I'll get 10 upon 16 sec square theta, and sec square theta will cancel out, leaving sec square theta in the denominator because it's sec 4 theta. Okay, so you have sec square theta dot d theta here. Okay, I have to apply the boundaries of pi by 4 and negative pi by 4. But firstly, I'm going to 5 upon 8. Sec square theta is actually 5 upon 4, 5 upon 8 sec square theta. So if I can just write it as 5 upon 8 sec square theta can be written as cos square theta here. Okay. Okay, we know cos square theta is actually can be written as 1 plus cos 2x upon 2 theta upon 2, which is 5 upon 16, 1 plus cos 2 theta. Okay, now I'm going to integrate it. I haven't started integration right now. 5 upon 16 as it is outside. Integration of 1 is theta. Integration of cos 2 theta is sine 2 theta divided by 2. Now I have to put the boundaries, which is pi by 4 and negative pi by 4. 5 upon 16, I'm writing it outside only. Okay, pi by 4 plus sine 2 pi by 4 divided by 2 is the first bracket, minus pi by 4 plus sine 2 minus pi by 4 upon 2. 5 upon 16, pi by 4 plus sine of pi by 2 is 1, so it's half here, minus pi by 4 plus sine of negative pi by 2 is going to be negative 1 upon 2. Okay, it's 5 upon 16, pi by 4 plus half plus pi by 4 plus half. Okay, so it becomes 2 pi by 4 plus 1 inside the bracket and 5 upon 16 outside, which becomes 2 1 times. Okay, if I multiply both of them by 2 pi by 4 first and then 5 upon 16 by 1. So if I simplify this, I'm left with 5 upon 32 pi by 2. Okay, plus 5 upon 16. If I take out 5 upon 32 as common, I'll be left with okay, just hold on. I have put this 2 extra here. Okay, let me solve this. So you're left with 5 upon 16, 5 upon 32 pi plus 5 upon 16. So if I take out 5 upon 32 as common, I'll be left with pi from here and 2 from here, which is the final answer. That's correct. Okay, moving on to this question. Use the substitution u equals to x minus 2 to find the exact value of this. Okay, so we know u equals to x minus 2. So du upon dx is going to be 1. So dx is going to be du. Okay, so let's put the value here. 1 plus x minus 2 is u. 1 plus u square dot dx. Okay, the boundaries are 2 and 1. But the boundaries are for x, not for u. So let's work on the boundary first. So we know u equals to x minus 2 and x की boundary is 2. So 2 equals to x minus, sorry. We know that u equals to x minus 2 and x is equals to 2. So 2 minus 2 is going to be 0. So this boundary is a 0 and the lower boundary is 1. So u equals to 1 minus 2. So u equals to a negative 1. A negative 1 here. Okay. So if I take out 4 as common, I'll be left with 1 upon 1 plus u square dot dx. And the integration of this is going to be tan square tan inverse of u. Tan inverse of u. Okay. We've done this in integration of tan inverse. Okay. Sorry, integration of this. We know that integration of 1 upon 1 plus x square dot dx equals to tan inverse of x. So this will be tan inverse of u. The boundaries are 0 and negative 1. Let's put the boundary now. 4 outside. Tan inverse of 0 minus tan inverse of 1. Negative 1. Okay. We know tan inverse of 0 is 0 only. And tan inverse of negative 1 is negative pi by 4. Okay, so 4 into pi by 4, which is a pi only. This is the answer to this part. Okay, here we come to the end of the recording. Thanks a lot for watching the video.